talking about the area of rectangles. We've got some warm-up activities that we need to work on. Now, this kind of goes into Module 1 just a little bit, where we multiplied decimals. But when you're doing this, I want you to follow my trick. So I want you to underline the decimal place values in each of these on the top row. And then we're going to talk about how many digits we underlined. Okay, now, block 1 thought, okay, it has to do with the zeros. If there's a 0 in front, I put a 0 in front. If there's 2 zeros in front, I put 2 zeros in front. If there's 3, I put 3. And that only works on single digit numbers. When we get down here to 12 and 35, it won't work anymore. So don't look at your zeros, okay? So the answer to 2 times 2.
4.
Okay. Now, 2 times 2 tenths.
0.4.
That's all we worked on in Module 1. We didn't go past that, okay? Now, it's tenths times tenths.
0.0.
No, just don't talk, okay? Tenths times tenths is the same thing as hundredths, because I have 2 decimal place values, and that means 2 to the right of the 0. So this time it's going to be 4 hundredths for your answer. And do you see the 2 digits to the right of the decimal, okay? So take a guess on this, Cheney. What place value do you think my answer will be in?
The thousands.
The thousandths, okay? And because I have 1, 2, 3 digits to the right of the decimal, it will be 4 thousandths, okay? Now I want you to go down, I want you to try this second row. But I want you to underline to keep track of what place value your answer will be in. So this time it's just going to be 12. Then it will be in the tenths place, the hundredths place, and the thousandths place. Okay? Give that a try. I'm going to pull a stick. Okay, how about George B? What'd you get for this next one? 3 times 4 tenths. 1.2. Awesome. Okay, the next one.
0.014.
You got it.
0.014.
And that would be, this would be 12 hundredths. Everybody say it with me. 12 hundredths. This would be 12 thousandths. Okay? All right, do the next row. Jair, do you want to get the door when you're done with this, please?
Yep.
Thank you. Okay, Chloe, I pulled your stick, so help me out. 5 times 7.
3. 5 times 7 equals 35.
Good. Now what?
3.5.
Good. How do you say this? Class?
3
and 5 tenths. Good. Next one?
0.3.
Good. How do you say this, class?
3,500.
3,500 hundredths. Okay. Tell me what to write here, Chloe.
0.0.
How do you say this one, class?
35,000.
35 thousandths. Okay. So if you run across a multiplication problem, let me give you a little, what if I had 19.2 times 3.5? What place value will my answer be in?
The hundredths.
The hundredths. How do you know that?
Because you have to underline.
How many place values did I? 2. So I will have 2 digits in the decimal place value. What about this one? What if I had 1 and 92 hundredths times 3.5?
Thousandths.
Okay, why do you think it's
Because
thousands?
there's 3 underlined.
There's 3 underlined, and 3 digits to the right of the decimal is what place?
Thousands.
Good job. Okay, let's keep going. So this, we've done a little bit of. We're going to practice some more today. So if I were giving you a perfect answer for this, here's how I would answer. You need to pay attention because I'm going to pull sticks here in a minute. We're going to multiply these two numbers. So I will do 2 times 4
8,
plus 1 more.
9.
So that would be 9/4. I'm changing the mixed numbers to improper fractions. Let's practice another. So I'm going to multiply these two. You don't have to circle it. I'm just showing you. 8
11.
plus 3, and my denominator does not change. Okay? All right, I'm going to pull some sticks. Vaughn. Okay, you got to tell me you're thinking.
No.
2 times 2 equals
4 plus
4 plus 1 equals, huh?
5.
Okay, so my answer would be 5/2, not 5/2. Okay, all right. So Abdiel, next one.
You multiply 4 times 3 plus 2,
Okay, what's 4 times 3?
12
Okay,
plus 2 is 14, and 14 thirds.
very good, very good. Next one for me.
16.
Okay, I don't want to know the answer. I want to know how you got the answer.
The 3 times 4
Equals,
8.
equals 12.
6 plus 3.
12 plus 3 is
16.
15. 15/4. Okay, let's do the next one. This is George A.
2 times 6, 12 plus 5, 17.
17.
6.
Good. Lexi.
3 times 8 equals 24 plus 3 equals 24 eighths.
27/8.
Yeah, 27 eighths.
The next one is Beverly.
Okay, so you're going to multiply 4 times 8, which will equal 32, and add 5, which will equal 37, and that will be 37
Perfect. Kind of knew it was going to be though. You ready yet?
5 times 8 is 40. 40 plus 7 is 47. So 47 eighths.
Good. Okay. Why would we need to know how to do this? I'm getting ready to show you. Okay? So this goes back to Module 4, which we didn't do much of. Someone remind me how I multiply fractions. And this is going to help you, Lynn, because you have some homework to do that's multiplying fractions. So let's just take 1/2. Don't write this. But just remind me what I do here. I'm going to pull a stick. Addison, how do I solve this problem?
You will multiply.
Mhm. So my answer would be what?
There would be 1 and 6.
1/6. Okay? Does everyone remember their sprint from last week?
Yeah.
Okay. So if that's true, then I should be able to do 3 times 2 and 1/2 times 1/3, right?
Yes.
In a perfect world, yes.
Yes.
But not in this world. Because what I'm actually doing, watch this. I'm actually doing 3 times 2 and 3 times 1/3. Then I'm doing 1/2 times 2 and 1/2 times 1/3. So a better way to do this, go ahead and write this, boys and girls, is the area model. So I am, okay, today our first number is going to be our length across here. 3 and then 1/2. Are you following me?
Yeah.
This will be 2 and this will be 1/3.
We did this.
Now remind me about that. Well, yes. Remind me about the area model.
Multiply.
I do, and I kind of multiply diagonally. So I'm going to take 2 times 3 and 2 times 1/2.
1.
1. So just a minute. 2 copies of 1/2. Is that one whole?
Yeah.
Okay. Then I'm going to take 1/3 times 3. 3 copies of 1/3. 1 whole. And I'm going to take 1/3 times 1/2.
1/6.
Then all I have to do is add all that up together.
8 and 1/6.
8 1/6. So that's one way to solve multiplying mixed numbers, okay? But that's not standard algorithm. And in the real world, we're gonna want to do standard algorithm, okay? So I didn't tell you this, but you need to somehow save yourself enough room to put 3 equal signs down there. Now I want to show you how to do this standard algorithm, okay? So help me out here. I'm going to pull a stick. We're going to change those to improper fractions like we did on the last page. Lorenzo, how do I multiply this to change it to an improper?
Multiply 3 times 2,
Equals
6.
plus 1 equals, so it's going to be 7 halves times. And Gavin, do the next one. Change this mixed number to an improper fraction.
2 times 3 equals 6.
Plus 1 equals,
7.
so it's 7/3. So what's 7 times 7?
49.
2 times 3. Go down here. Write down long division. Write this. Skip count by sixes with me. 6, 12, 18, 24, 30, 36, 42, 48. Stop.
8.
Minus 48.
48. 6 times what equals 48?
1.
6 times 8. Do you remember how I taught you to take your
Yes.
remainder, put it on top of your divisor, and you get a fraction? Is that the same answer we got with the area model?
Yeah.
It sure is. Okay?
Wow.
So the goal is to be able to do it standard algorithm, but we're going to start with the area model, and we'll start doing that tomorrow. Okay? All right, let's do the next one. Okay, so if I put this on the area model, you do not have to write this. I'm just showing you the difference, okay? So it's going to be 3 1/3 times 2 3/4. 3 times 2 is 6. 2 times 1/3. Okay. 3 times 3/4. Anybody know what that is?
9/4.
9/4, which is 2 and
1/4. 2 1. 2 and 1/4.
and 3/4 times 1/3.
3/12.
My goodness, we have a lot to add up. I don't want to do it. Do you?
Nope.
Okay. Okay, so let's do it the other way. What's 3 times 3?
9.
Plus 1 more.
10.
So write down 10/3 times 2 times 4 plus 3, 11/4. So I get 10 times 11. Anything times 10 out of 0 to the end.
110.
Okay. Now I can tell right now I'm going to have to simplify this when I'm done. Because they're both even numbers. So count by 12s for me. Can anybody sing my song?
12, 24, 36, 48.
12, 24, 36, 48, 60, 72, 84, 96, 108.
108.
1, okay, so 110 divided by 12, 108. 12 times what equals 108?
9.
9. So I've got 9 2/12 here, which can be simplified to what? 9 1/6. Okay, I think I really like the standard algorithm that time. Okay, the next one. Should we mess with putting this on an area model? I think we'll just do the standard algorithm. Okay with you? That wasn't 7, that was 9, so I don't know what I'm thinking. Okay, so 3 times 5.
15.
Okay, someone besides Cheney. I think I'll pull a stick. Emily, change this one to an improper fraction.
15 plus 4. 20. Or 19.
19 fits. Good. And that child is gone. Cadence. Change this one to an improper.
14 thirds.
14 thirds. So 4 times 3.
Oh. And then add 2 and then, yeah.
That's pretty simple, isn't it? Okay, 19 times 14. Now, you know what I was looking for? Ways that I could look at these diagonally and cross something out so I wouldn't have to do 19 times 4. But there's nothing. They don't share any factors. So here's what I want to remind you. X's and O's. Standard algorithm, turtle head method. Okay, what'd you get?
266.
266 fifteenths. Well, long division again. Can I chunk this?
Yes.
Yes. Where?
26.
26. Now you could count, skip count by 15ths. 15. But I don't really want to. Because I want to start with 1. Ooh, I'm still in red, sorry. And that gives me 11. Is 11 less than my
Yes.
divisor? Okay, bring down your 6. Now, I think I can skip count by 15s, but I know that 15 times 6 is 90. Right? 30, 60, 90. I've written this for you several times. I'm going to write it again because I want you to remember. Is 15 times 6 90?
Yes.
Okay? So I could add another 15, and what would I get?
7.
90 plus 15.
105.
105. So that's how many 15s? 6 plus 1 more? 7. So my answer to this one, boys and girls, 17 and 11 fifteenths. So that's the goal, to be able to do that on your own, okay? We're going to start from the beginning, though, and go back to drawing it, okay? And we'll get to that in just a minute. So let's take a look at this application problem. Okay, Heidi and Andrew designed 2 raised flower beds for their garden. Heidi's flower bed was 5 feet long by 3 feet wide, and Andrew's flower bed was the same length but twice as wide. I think that's pretty important, don't you? Twice as wide. Calculate how many cubic feet of soil they need to buy to have a soil to a depth of 2 feet in both flower beds. Okay, so what I want to do is I want to draw Heidi's flower bed. So let's get Heidi's on there. Now here's the trick. You're going to go a long skinny rectangle. Then you're going to go back. This is going to look like a flower bed, hopefully. Not perfect, but it'll work, won't it? This is Heidi's, and it's 5 feet by 3 feet wide. And then how tall is it? It never tells us. It says there's going to be soil to a depth of 2 feet.
Then it's 2 feet.
Then it's 2 feet. And we're going to have soil here, right? And it'll be 2 feet high. And you could color in your soil brown or whatever if you wanted, but we're not going to. So how much soil do they need to buy? You know, you can buy that soil in bags, big bags.
Yeah.
Okay? So first thing I need to do is figure out Heidi's, then figure out Andrew's, right? So let's put Heidi's volume equals and Andrew's volume equals. And Heidi's is pretty simple. I'm just going to calculate the volume. Now don't tell me what it is, just work it out. And if you remember correctly on Friday, I gave you a new format to use. So I want you to use that format. And don't forget your label of cubic feet. So it looks to me like Heidi's going to need 30 cubic feet of soil. Andrew's going to need more because we're doubling what? The width. It says twice as wide. So which number here is the width?
3.
So instead of 3, this time we'll have what? 6 because we're doubling it. So it's going to be 5 feet times 6 feet times 2 feet. And use the same format with the 3 equal signs. How did I get my total, Jair?
You add 30 feet cubic over top and plus
60
feet cubic. Yeah.
equals
890.
cubic feet.
Yeah.
Or feet cubed, however you want to say it. So, probably going to have to buy more than one bag to get 90 cubic feet. I don't know how many I don't know how much soil's in each bag you buy. Okay? So that's a pretty typical volume question. You think you could have done it on your own?
Mm-hmm. Yeah.
I feel very confident that you could have. Okay, so let's take a look at the lesson today. Now, we're going to go back to square one. And you don't need to draw anything yet. I just need you to help me figure this out, okay? We've got to use our brains here to figure out how I'm going to cover this rectangle with tiles. And in my directions it says to use paper to do this, but I thought this would be easier and plus I think it's more fun, okay? So, rectangle A, here we go. Should I just start dragging them and see what fits? Okay, let's start with 1. You think it's going to be 6? Okay, so let's see if that works.
Yep. Yeah. It's perfectly.
Okay, so this is going to be called tiling. If you hear tiling on Zern or anywhere, okay, that's what it is. Now you're going to draw, altogether you're going to draw 5 rectangles on your paper, okay? But don't draw it yet, because I want to talk about a couple things. First thing I want to talk about is, what would the measurement of each tile be?
1 6.
One what?
6.
1 unit. And what's my label?
3.
No.
This is area.
2.
Squared?
Squared.
Squared. Or square units. So this is 1 square unit. Okay? This is 2 square units right here, correct? How do I get 2 square units? Well, I count 1, 2. But what if I needed to write something on the side of my rectangle?
You could do 3 times 2.
I could. So I could do 2 units here, don't write this yet, and 3 units here, correct? And I could multiply. And I can even do that if my square units were gone, couldn't I? As long as I have my rectangle labeled. As long as I know my lengths. And today we don't know if it's inches or what it is. So we're just going with what is written down. Okay, now here's what I want you to draw. So over here to the side, I'm going to draw it for you. I want you to make a rectangle. And that was a total of 6 square units, wasn't it? So divide your rectangle like this. And each one of these is 1 unit squared. So I want to write 2 units by 3 units. Okay, there's another way I could do it. I could put my ones in there for 1 square unit, couldn't I? Or 1 unit squared. And I could just count them. And I could get 6. But let's go back to multiplying. So the length is going to be across the top today. Okay? You know, normally I do length times width. But today, length is across the top. So 3 units.
Times 2 units equals 6.
And this is 6
Units squared.
units squared. So it has to have a 2 on it. Okay? That's kind of what we're doing today. But we're going to have fractions in there. So let's look at the second rectangle we need to cover. Okay. Well, should I start with my ones again?
No.
Well, I got 3 across again.
It's gonna be
9.
9. It's gonna be 9.
9.
You think it's going to be 9?
Yeah.
Oh, no,
Alright.
no.
Oh.
You could just do 4.
Wait.
I think half.
You think half?
Yeah.
Sideways.
Sideways.
That's
Oh,
what I was
good.
thinking.
Like that.
Yeah, sideways.
Well, I'm not perfect, and my half doesn't look like it's long enough, is it?
Ooh.
Good job on the sideways, whoever said that.
Jeremy.
Yes. Okay, so that's pretty close, isn't it? So, I'm not going to take all these off again, but I want to figure out what my measurements are here. Now, I know this is the same. What is it?
3 units.
3 units. Don't write yours yet, okay? And this is
2.5.
2.5.
Units.
Okay, so my multiplication problem to go along with this one is actually 3 times 2.5. So when you draw that, somewhere write that multiplication problem. So we're going to draw it. It's going to be a little bit longer than last time's rectangle, closer to a square, isn't it? Okay, so go ahead and draw it. And this is actually going to be rectangle B. So I know I had 3 across. So start with that. And then I'm going to just kind of eyeball it. And this was 2.5. And labeling it, I watched the video this morning, and this is 1/2 square unit. How do I get 1/2? Look at this. I take 1/2 times 1. Did you see where I drew my arrows? That's 1/2 times 1, so that's 1/2 square unit. Okay, so my total area this time, and I want to keep in mind that a half plus a half is a whole. Okay, so this could technically be 1 whole, couldn't it? Okay, so I've got 6, 7, 7 1/2. 7 1/2. Okay, now I remember where my 7 1/2 came from. Rectangle B. Okay, so let's write, now our length is going to be across the top today. So 3 1/2 or 3 units. And then 2 1/2 units equals,
7 and a half.
7 1/2 units squared.
good. And I'm going to do U2. How's that sound?
Yeah.
Okay. Now, I want to remind you of another way to solve this problem, but I don't like it as well. Okay? And it's before this in your math education. So we could do 3 copies of 2 1/2. So if I write that, it's going to be 2 1/2 plus 2 1/2 plus 2 1/2. So that's 2, 4, 6, right? And then a half plus a half is a whole, and we would have got 7 1/2. Okay? That's another way to solve it. All right, fist to 5 on what I've done right now. Pretty simple if we draw it, right? Okay, so let's keep going. This one's going to look a little different. It's taller.
Well,
In fact, I'm going to have to change how I view it on there. Okay, so should I start with the one hole again? Okay.
And then
And
but
what-
also
1 1/2?
yes.
It just goes down.
It just goes down. So how far do you think it's going to go down?
4, 5.
5? You think it's 5? Let's see.
5 or 6.
5 or 6?
5, I think.
Yeah, 5.
Okay.
Then you put that out.
And then put the half on. And then I need you to be thinking about, just a minute, be thinking about how I need to label this. Okay?
I know.
Just don't say it yet. Okay, so Miguel, what measurement would go here?
1 1/2.
1 1/2, and we're going to call it units, aren't we? Okay. And what measurement would go here?
5.
Yeah, Jesus was right when he guessed 5. That was good.
We have 3.
Okay, now let's draw it. So when you draw it, you're just going to draw something tall and skinny. Now, I know this is 5 units, so how many lines do I need?
4.
There you go. So divide it in with 4 lines. And then just kind of eyeball a half. How does that sound? Okay. Label it. And then let's label inside, because I really feel like that helps us solve it easier.
We're also just copying from the box.
We are. We're just copying what we just did. Okay, so now I don't want to do 5 copies of 1 1/2. I just want to count all this. So let's find my 1 holes first of all. Whoops, I meant to go to red.
Oh, there's
Hold on.
2.
So here's a hole,
and then
and here's a hole.
2 1/2.
So 2 1/2. So we're going to add 5 plus 2 1/2, and it's going to be, there's that 7 1/2 again. This is rectangle C. The length is 1 1/2. You can write U. The width is 5. You can write U.
7
7 1/2 U squared. Okay, how are we doing?
Good.
Pretty good? Okay, we've got 2 more.
What about 7 and a half?
Oh, thank you, Lexi. Did I write 7 1/2 on the last one?
Yeah.
Yeah.
Goodness. There you go.
And then it says 1.
Okay,
1 and 1.
that's right. So the next one.
There's
Hmm.
2. There's going to be.
You think it's 2?
I think
Yeah,
it's
2
good.
down and 3.
Yeah.
2 across?
Give me
4.
No, it's the 3
It's the 3 halves sideways.
Is the 3 halves?
No,
Sideways.
3/4.
3/4.
3/4. Okay.
Sideways.
3/4 sideways.
No. Right?
Mhm.
Oh, and then
And then.
That's not perfect sideways, is it? And then I'm going to duplicate that
Why can you not just do that for me?
you should do
because I don't want to turn it again. The turning's hard. Okay, pretty close. All right, so what do I have on the top here?
2.
2 units. What do I have
1
on
and 3/4.
3/4? 3/4? 1 and 3/4 units. Okay, so it's almost a square, but not quite. And then, about like that.
I did it.
1 and 3/4 units. 2 units. So then go ahead and label it with your numbers. Now I'm gonna ask a question. Don't shout it out. Who knows what 3/4 plus 3/4 is?
Me.
You do?
Yep.
What is it?
7/8.
Well, but let's say mixed number.
Oh,
1 and 1/8.
George A.
1 and 1.
1.5. Yeah, because I would do 6/4,
Oh.
which equals 4/4 plus 2/4. Is that 1 and 1/2?
Yeah.
Yeah. So 1.5 plus 2.
I was the one to say that.
What's the answer?
I wasn't in
This is 1.5.
1
This
and a
is
half
2.
plus 2 equals
3 and a
3
half.
and a half.
3.5. I'm getting the answer on there right away this time. Okay, so rectangle D, 2 units by 1 and 3/4 units equals 3.5 units squared. All right, one more.
Oh, it's gonna be 1/2.
No,
I think it's 3/4.
Okay. It's not 1/2.
Okay, it's gonna be the.
I think
Yeah.
it's 5.
You think it's 5?
Yeah, 5.
Yeah.
6.
You want to change your prediction?
I said 5.
Oh, you did? I thought I heard you say 6. Okay. I'm just teasing. So this is 3/4 units. Now, you might see it looking like this on Zern. And it's actually divided into 3, and each of them say 1/4. Okay? So it might not be grouped together. I was just lazy and I didn't want to drag that many. Okay? But it might be like this and it might say 1/4, 1/4, 1/4. I don't know. Okay? So what's on the side? 5 units. Okay, so go ahead and draw this. To get 5, I need how many lines?
4.
Okay, there's a couple ways to figure this out. I could do that thing where each of these is 1.5 if I put 2 of them together. There's an easier way though. Because then I have to add 2.5 plus 3/4, and then we have to change the denominator and all that. So I could do repeated addition. That's actually easier this time. I'm going to run out of room. So that's going to be how many fourths? I think it's 15.
Yeah, 15.
15 fourths. Change that to a mixed number.
3 3/4.
3 3/4. Okay, so here's what I'm gonna write. For rectangle E, I'm gonna write 3/4 units
Times 5 squared.
times 5 units equals
3 3/4 units.
3
squared.
3/4 units squared. Okay, we'll finish tomorrow with the problem set.